Hello friends, welcome to the new session of data science programming using Python. In this session, we are going to learn about the cross validation techniques. Cross validation technique, out of many techniques available for validation, we have seen one of the technique to validate your data, whether the data is suitable for the algorithm or not, or algorithm is suitable for the data set or not. This validation we have already done with the help of one technique called as train test split. Now we'll be covering few more other techniques available for the validation of the data here in this session practically. Now before actually going towards the validation, I'm going to cover two important topic. Theoretically you must be knowing it already. We have seen these techniques, this overview of this technique, these particular theoretical terms in ensemble learning, but let's revise it. Maybe that will be useful for us in cross validation. So in the current video and the next video, almost similar kind of validation, means similar kind of techniques will be making use of them. Their application is same, maybe their techniques are different, so just focus on the theory part behind this. First, let's see what do you mean by the overfitting. Overfitting means the model has trained too well and now well too closely related to training dataset, almost achieving the 100% accuracy there. This usually happens when the model is too complex, that is, too many features, variables compared to number of observations are present there. This model will be very accurate on the training data, but will probably be very not accurate on the untrained or the new data. Okay, training data is perfect, but when you are going to make the testing onto it, it is not giving the correct results. So overfitting occurs. Overfitting is a problem that the data that we are taking for the training is perfectly selected, but after that when you actually work on the real test data, this is not working fine. So that's why overfitting occurs. This is because this model is generalized or not as generalized, meaning you can generalize the results and can't make any inferences on the data, which is ultimately what you are trying to do. Underfitting, the second terminology which is almost connected to the overfitting. In contrast to overfitting, when a model is underfitted, it means that the model does not feed the training data and therefore misses the trains in the data. So it is difficult for the algorithm to find the train, to find the novel insights in the data. Because of underfitting, this happens. It also means the model cannot be generalized to the new data. As you probably guessed, that is usually the result of very simple model, enough predictors or independent variables. It could also happen when, for example, we fit a linear model like linear regression to the data which is not linear. Okay, it almost goes without saying that the model will have poor predictive ability on training data and can't be generalized to others data. That is what we call as underfitting. So underfitting reduces the accuracy drastically, so it's not possible, or the data is not possible to get fitted into the statistical model of the algorithm. That case underfitting happens. Let's see how exactly this can be demonstrated with the help of the diagrams. Check it out. Now the first diagram which is shown over here, it is underfitting. Now see, the trains are not actually connected to the line. So here in linear regression, all these points should be close to the center of this line, but they are not actually close, they are somewhat far away from it. It's what we call as underfitting. Now this is generalized terminology that I'm going to create a equation over here. This is what we call as a common model available or created by the machine learning algorithm here, and this is what we call as overfitting. Overfitting is almost perfectly matching with the training data, but when you apply on testing, accuracy decreases drastically. This is what we term as overfitting. Now to remove this overfitting and underfitting, ensemble technique will help us, but along with that few more cross validation technique will also help us, that the data is having uniform accuracy throughout or not, or some set of data is having good accuracy or other set of data is not having that much accuracy. That identification we can do with the help of the cross validation techniques. Now let's go with underfitting. Now it's worth nothing, underfitting is not as prevalent as overfitting. Nevertheless, we want to avoid both of these problems into data analysis. You might say we are trying to find the middle ground between under and overfitting our model. As you see, train test split cross validation will also help to avoid overfitting more than the underfitting. So basically what train test split does, I'll just revise, we already seen this in many algorithms. Train test split divides your data in two different parts, that is training data and testing data. Training data is almost 75% that we consider by default, and 25% is the testing data. Randomly this data is selected so that the validation of the data can be done correctly. So but we train our algorithm by a single set of training data only. Now rather than doing it, we can have multiple sets of training data so that validation of the data can be done correctly. Okay, that's what cross validation technique will do for us. Now it's similar to train test split, but it's applied to more than one sets, that is subsets. Meaning we split our data into k subsets and train on k minus 1 one of those subsets. What we do is to hold the last subset for the test, we are able to do for each of the subsets. So rather than creating only two parts, training and testing, we'll create k number of subsets and every k will train with the algorithm, and then we try to find whether this data is suitable for the algorithm or not, or every subset of the data is giving similar kind of training, similar kind of the accuracy in the algorithm or not. Okay, now let's see how exactly we do. Here data set we basically convert into two parts, training data and testing data. So here we have holdout method. This is what generally we perform the operations. One more way is present there, that's what we call as a data permitting. So where data is converted into three different parts: training, testing and validation. Training, testing and validation. So training will build the model, validate will check the accuracy, and testing will use for predictions. So this is also one of the technique that we can do. Or one more, this is what cross validation will do. We'll convert this training data into small parts. This is just generally we term as a k-fold cross validation. With the help of k-fold cross validation, we convert this part into multiple parts, like 10 parts, and every part will be trained with the algorithm, and then it will check against the testing data to check whether that data is trained, model is trained perfectly with the data or not. Which means that validity of the data can be found for the given algorithm. Now there are many cross validation techniques are available, but out of all I'll be showing two different techniques over here. Actually we are going to see four techniques. Out of that, these are the two commonly used techniques that we'll see, and after that I'll show two more techniques. So first two techniques are k-folds cross validation, and second is leave one out cross validation, that is LUCV. After that we are going to see the stratified k-fold cross validation and grid search cross validation. Now let's start with the first technique, that is k-fold cross validation. First technique is actually train test split. This we have already seen. We are going some at advanced level, so whenever is required to find the validity of the data, we are going to make use of these techniques. In k-fold cross validation, we split our data into k different subsets, that is what we call as the folds. We use k minus 1 subsets to train our data and leave the last subset of the last fold as a test data. Then we average the model against each of the folds and then finalize our model. After that we test it against the test set. Now let's see graphically how exactly this validation technique performs. Now here see, this is your data set, training data, and then I have converted some k folds. So here 1 2 3 4 5 6 7 8 9 10. So k value of k is 10 here, so I have converted 10 parts. Now in first round, first part is taken and checked for the accuracy, that is 93% for example. Then second part, then third, then fourth, fifth, 10. So after 10, every part is checked against the accuracy checking, and final accuracy will be the average of all. So if it is going above some good or validate accuracy, then only the data set can be considered for the given algorithm. Okay, this is what we call as the k-fold cross validation. So here also, just like algorithm that we have seen, k means for clustering, knn for classification, k-fold for cross validation, value of k we have to define. So let's go with our original data set. We have already seen this data set for linear regression, where experience and salary, these two columns are given. We consider that experience and salary are considered or connected by the linear model. That is, when years experience increases, salary also increases. And we have already performed this particular technique, linear regression, with the help of linear regression modeling, and there we have used the trend test split. Now I am going to show you how can I make use of the k-fold cross validation for this particular algorithm here. Now let's go. This data set is already known to us. I am going to use this file, this data in the CSV file in data frame, and then afterwards we are going to make use of this. We are going to build the model based on this data. And now let's see how to do this one. Okay, so my file is available with me. It's salary underscore data.csv, which we have already seen. I'll just open that file again. Okay, so let's go for this particular file. Okay, so these are the cross validation files. Let's see. This is your salary data, which I am going to build a linear model over here. Okay, so I need to read this file first. Check this. Total 30 entries are present inside the file, and let's go for using this. Okay, so first of all, I have imported the k-fold. So k-fold is also present into the same sub package, that is model selection, where the train test split function is also present. But I have the k-fold is the it's a class. The train test split is a function. Then import the pandas. After that, I am reading the CSV file into the variable df, and as we know already that the ES experience is the input variable, which I am converting into the array format and storing in X, and then reshaping it to two-dimensional array with the help of X dot reshape minus 1 1. Okay, so X will be the input variable now, input feature, that is years experience for this case, and Y is salary, that is the output variable df. I am storing into variable y. Fine. So we have separated X and Y variable here, input and output variable. After that, I have to do the k-folds. So create the object of k-fold here. So k-fold is a class which we have imported from the model selection, and now creating the class object. Number of splits I have mentioned are 5. Shuffle true means fold can be anything. It's just not considered that always sequential folding is done. I am going to shuffle the data, which is true, and random state I am keeping 0. So randomly the seed point kept as 0 here. So object kf is created for the k-fold. Now let's enumerate the splits. There is a method for k-fold that's called as a split, which is used to do the split. So 5 splits will be there. From that particular splits, I'm going to read train and test data separately. Then I'm printing this train and test data on the screen. Okay, so let's enumerate that. Check the output of it. Now see this one. For this case, we have given this value. So train, this is a train data for first k 0 1 2 3 4 5. So 5 folds I have given. In the first phase, the training data is this. Okay, so we just check it out. 1 3 4 5 6 7 8 9 something, they're going on, and then 2 10 13 24 26 and 28. This is the testing data present here. So 6 entries are present here, and remaining 24 are present into the training data. Okay, in first phase. Okay, now in second k, the values are changed now. 0 1 2 3 4 6, like here. Check this out. This data is changing. In first phase different, second phase different, third phase, fourth phase of k-fold, and last phase of k. Every time when I split my data, 5 number of times these operations are done, and data sets are completely changed. It's not like trend test split, only a single static data is generated. So here 5 number of times, 5 different splits I got for training data and testing data. Correct. Now these splits I'm going to make use of it in validation of it. Now let's see how to do this validation. So let's build the model first. I'm reading the sklearn.linear model, import linear regression. and after that create the object of linear regression model. Here this is the object of linear regression model. And now making use of this, now let's see training accuracies. Same for loop which was used previously, I'm using the same way. Here train tests are splitted, that we already seen here, and this data I'll be providing. Okay, remember these are the index numbers which are generated, only index numbers, means number of the row which are generated, and that specific rows I'm first training I'm giving to X, and specific rows from same in Y. So this is train, X input, Y input, the same number of rows, same number of rows in input, same number of rows in output, which I am providing over here, and building my model. I am training my machine learning model of linear regression here. Okay, now once the training is done, as we know, score function of linear regression will give us the accuracy for the given training data. Okay, so 5 folds are there, 5 times data model will get filled with different set of data sets, and every time we are going to train it, we are going to find the accuracy of this particular model. So I executed it, check it. First phase 94, 96, 96, 96, 95. So within the 94 to 96 only, these accuracies are varying. It means that there is no much variations present in the data. So this validation passes. Okay, if you go for testing data, so here I am checking splits, training and testing, but now I am fitting the testing data, which is containing only 5 to 6 entries present into it, then fitting it and printing the accuracy of the testing data here. So let's see, check it out. 99, 93, 95, 92, 97. So minimum 92, maximum 99. These are the accuracy that testing data set is carrying now. Difference is somewhat larger, but it is almost 7% difference is there, but okay, it's above 90%. So in this way, this validation of the data can be done on the given model, not only for linear regression, but for other models also this will work. So we are having one more algorithm called as stratified k-fold, which will work correctly for the classification algorithm. This is what the regression algorithm is. Now there is one method by which you can find the cross validation score. Cross validation score will tell you how exactly the cross validation technique is perfectly applied for the given data. So to do this one, in model selection package I am having one function called as cross val score, cross underscore val underscore score. With the help of this, we are going to make use of find the cross validation score for the respective object of machine learning. So here object is REG, the linear regression model, input is X, output is Y, and how many cross validation we require, that is 6. So if you run this one, so this cross validation score will be given by using cross val score. You can check it out, these are the cross validation scores. Okay, so these scores are close to the zero value, close to zero values. It must not be too much larger or too much smaller. So it's fine, it's okay that 6 times I'm validating the data, and every time I'm almost getting the close towards the zero. Okay, so this is how the common k-fold cross validation technique should be used into the programming. So that's what I've shown, it's shown over here also. Now apart from k-fold, okay, this technique can also be used in our regression method, you just can find it, and not only regression but in classification also this technique can be easily applied, which I shown in the code. You can make use of it, cross validate it for creating number of folds into it, 5, 10, 20, whatever you require, and check it whether throughout accuracies are common, same or not. Now second method is loose EV, that is leave one out cross validation. In this type of cross validation, the number of folds, that is subsets, are equal to the number of observations we have in the data set. Number of observations in the data set. Then we average all of these folds and build our model with the averages. Okay, we then test the model against the last fold, because we would get a big number of training sets equal to the number of samples. This method is very computationally expensive and should be used on small data sets only. If the data set is big, it would most likely to be better to use on different method like k-fold. See this one. What do you mean by this? So leave one out. So one fold I'm going to make it separately. For example, value of fold is n, and these are the folds created here. Okay, so every time your model will be built, so this is what your testing data is, here, 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 and go till last. So when your data set is too much higher, it will take too much time. Low CV will take too much time to validate your data. Okay, so at a time, this particular single part, so where number of folds equal to number of observation we have in the data set. Remember, so one is separately taken, that one observation, and against other this observation will be validated. That is what we call as loose CV. Now let's see how do I make use of the loose CV algorithm over here. Now again, in the model selection itself, we are going to have leave one out class. With the help of leave one out class, we are going to make loose CV cross validation technique. Now let's see. So from sklearn.model selection, we have to import the leave one out class. So let's import that, and now create the object of it. So loo is equal to leave one out. So I'm not going to specify anything, because depending upon the length of the data set, one variable is taken out, one row is taken out, and then it will be validated against the original remaining data which are required to find. Okay, now see, leave one out, and then how many splits are possible in X? That is 30. 30 is actually the length of X, means total number of element, input element rows that X is containing are 30. That's why if you write loo.get n splits 30, so total number of rows will be 30. So 30 splits are possible into it, because individual row can be splitted separately. And now after this, we are going to check the training accuracy. So method which we used on k-fold is almost same as that we used in the loo also, that is loo CV. Now let's see training accuracies. For train test in loo.split, so split returns these two values, training rows, number of rows in training, and the testing rows. Okay, split that X, and now train and train, that is X train and Y train. I'm going to fit it. Okay, and then we are going to find the length of X train, means how many number of element that training is containing out of 30. Okay, how many number of element actually it contains. Okay, then we are going to find the score of it, X train, Y train into 100. So total number of times that it work is number 30. Now let's check it out. Here 29 elements are taken, only one element is discarded, one element randomly is discarded. Okay, and after that remaining 29 elements are fitted. Okay, they are fitted. So if that element is an outlier, if it is an outlier, so it will change the accuracy of algorithm drastically, and if it is not an outlier, it will not have any effect in the output. So see, length of X train every time it is 29, and focus on the accuracy. I'll just make it in comment. Now see, these are the accuracies of 29 element. Every time one element is left out, and remaining others 95 throughout carrying. This is 96, and all others are 95 almost everywhere. Means no much changes in the accuracy of this data. Okay, it means that throughout the validation of the data is good. If it is changing accuracy drastically at somewhere, so you just have to remember that the element which is left out can be the outlier. So in previous video we have already seen how to remove the outliers, so that outliers can be removed if there is drastic change in the accuracy. If one of the data or two three rows are showing the accuracy less than 80%, it means that they are involved with the outliers, and then outlier removal, detection and removal is required for this particular data set. Now for this case, outlier detection and removal is not expected or required, because now training accuracy for all is almost uniform. That's why leave one out cross validation technique can also be used as per our requirements to check whether the data is valid for the given algorithm or not. Okay, now let's come to the third cross validation technique here, that is stratified k-fold. Stratification, what's that? It's a process of rearranging the data so as to ensure that each fold is a good representative of the whole. Okay, each fold is a good representative of the whole. For example, in a binary classification problem where each class comprises of 50% of data, it is best to arrange the data such that in every fold each class comprises of about half of the instances. Remember, each fold should comprise of 50% of instances, not perfectly random. Okay, this is generally better approach when dealing with the both bias and variance. Randomly selected fold might not adequately represent the minor class, particularly in cases where there is a huge number of class imbalance. Class imbalance means when in output variable only 2-3 possibilities are there, so every of the class should have same number of entries into the data set. In the upcoming videos, I will show what do you mean by imbalanced data set and how to work on that imbalanced data set also. Before that, just focus on the stratified k-fold. Now let's see this one. Here in stratified k-fold, for example, I am having here 5 folds present here, and every fold should have equal number of class entries. So here, for example, 0 and 1 class is there, 0's class are 10 and 1 class are 30. So everywhere here 10 30 10 30 10 30 10 30 will be carried. Here also 10 30 10 30 all are, means uneven number of elements are not allowed, or even that not possible there. So generally in the classification problem, stratified k-fold is applied and used where uniform number of classes, okay, in case of imbalanced data set are available and possible. So every time we'll have, okay, here whatever class present, number of elements are present, here also same number of elements are there, here also same number of elements are there. Okay, and this is what we call as a stratified k-fold algorithm. Stratified k-fold basically used for the classification problems. Now let's revise our decision tree algorithm. Now in decision tree algorithm we have used this data set which is banknotes. Okay, I'll just open that and then we'll go for checking it. Okay, this one. So in the banknotes, we know that these are the properties of the notes which are scanned, and based on that the class, that is whether it is fake or the original note, that is identified. So variance, skewness, kurtosis, entropy defines the class of it. So two classes are there, that is we are having a class 1 and class 0 like this. See, so image properties defines that whether the note is coming under fake category or original category. So we have only two classes present over here, and this problem we already solved by using two algorithms, that is decision tree and the random forest also. So I'll focus on decision tree here, how this class balancing is possible into the stratified k-fold, that we'll see. Now let's go for that. Now stratified k-fold is a class which I'm importing from the model selection subpackage. Okay, then from tree I'm importing decision tree classifier, and then for finding accuracy of algorithm I'm having accuracy score function. Okay, so let's run this. Now read our file banknote.csv. Out of this particular file, I know that class is the output variable, so except this variable class I'm going to use other variables in X, that is first 4 which are shown over here: variance, skewness, kurtosis and entropy, and output variable is class. So X is 4 variables and output variable is a class. Fine. Then create the object of decision tree classifier, which I am creating over here, CLF, and then the object of stratified k-fold, where I am keeping number of slits are 5, shuffle true, and end up state is equal to 0. Okay. Yes, so that's created. Fine. So splits will be 5 for our case in stratified k-fold. So stratified k-fold basically we apply for classification algorithms. Okay, now let's use in the same way. So this method is also used in the same way by using the split method. SKF is the object of stratified k-fold. Okay, and split is a method which we use to split our data into the train test format. Okay, so training data and testing data on X and Y. So 5 folds will be there. 5 times we are going to have different training and testing data. So different input and different output. Okay, so here whatever numbers are taken, that numbers I am providing to extract ILOC, and exactly that entry input and that entry output will be extracted, and then the classifier will be trained along clf.fit. Okay, once the algorithm is trained, we are going to predict the data on remaining testing entries X of test. Okay, and then we are going to have the predicted values out of it, and finally we are going to check the accuracy of these algorithms based on the predicted data on the test data set, that is X test. So accuracy score, I'm printing y.iloc test and predicted. Okay, so which are originally available with us into predicted values into 100. So 5 folds, stratified k folds are taken, and based on that accuracy is defined. Check this out now. First fold 98.5, second fold 99.27, third fold 98.90, fourth fold 98.90, and the last 96.71. So though we have changed the folds, we have not having much differences in the accuracy for this case. That is what we call going to have the stratified k fold here. So stratified k fold can be applied specifically to these set of algorithms, that is classification algorithms. I can make use of it in random forest also, or you can make use of k nearest neighbor, support vector machine, new based classifiers also. So this is the way how we can make use of the stratified k fold algorithm here. Okay, so we can make use of and check out the cross validation score of it. So let's use the cross validation score for the same. Yes, scores, cross validation scores CLF XY and cross validation are 6. So 98, 97, 97, 98, 99, 98. Perfect. So cross validation score is same, means almost equal throughout all the cross validations, so that's fine. We can make use of this. And now I can make use of the cross validation predictions. That's also possible. You can make use of the cross validation prediction, cross validation score already. Okay, already we have seen that above. Now predictions, cross validation prediction on this algorithm. I'm going to make use of X and Y and then do the validations of it. Check this out, how the cross validations are considered. See this. Okay, this is not much expected here. I'm going to have the X and Y. Okay, so I think our regression algorithm is different here. Okay, so use these predictions. Now let's see cross validation predictions, how by using cross validation also, if you do the predictions, how they are matching, that also I'll show. So regression and X and Y. So X and Y, not this one, I'm going to use this X and Y, which one, salary and experience for a regression object. So I executed this, then I come below, then cross validation score for regression, this is input, this is output, 6 number of times, and then based on that I'm going to have the predictions. Okay, check the predictions. Okay, these are the predictions on cross validations. They are also coming linear, and it means that your algorithm is perfectly fine, means your data is perfectly fine for the given algorithm, and it is passing all the tests to get used for this algorithm perfectly. Okay, so this is how stratified k fold is used and it can be applied to us. Okay, they are the predictions. Now let's come with the end of this particular video. The last topic, parameter selections. Machine learning model has two type of parameters basically. The first type of parameters are the parameters that are learned through the machine learning model, and second type of parameter are called as hyperparameters that we pass to the machine learning model. Okay, normally we randomly set the value for these hyperparameters and see what parameter result in the best performance. However, randomly selecting parameters for the algorithm can be exhaustive. Just take an example. In k nearest neighbor, how to define the value of k? How to define the value of a random state, or how to identify which kernel is suitable for SVM algorithm or feed this data? Okay, what's the ideal values of these hyperparameters are, that we can't identify. We have to do this by using trial and error method. So this parameter selection is simplified with the help of grid search cross validation. It is not easy to compare performance of different algorithm by randomly setting the hyperparameters, because one algorithm may perform better than the other with different set of parameters, and if the parameters are changed, the algorithm may perform worse than the other algorithms. Therefore, instead of randomly selecting the values of parameter, a better approach would be to develop an algorithm which automatically finds the best parameter for the particular model. So grid search cross validation is one such algorithm. Out of multiple possibilities, which is the base possibility that will be outputted by the grid search cross validation here. Now let's use this. Use the data set called Wisconsin breast cancer data set. We already used the data set, so it will be simplified for us. And the algorithm which I am demonstrating along with this CV is the K nearest neighbor. Okay, so K nearest neighbor we will be using over here. I'll just show the data set first. Breast cancer analysis, that is Wisconsin breast cancer analysis. We know that these are the dimensions of the tumor detected in the body, and based on that we are finding the diagnosis. Diagnosis is the output variable. Total 30 inputs are there, remaining other except ID parameter. These 30 inputs are present. Okay, and based on that we are defining what diagnosis that they carry, is M or B, that is malignant or benign. Okay, and let's check it how to make use of this. So grid search. So first of all, importing the libraries, okay, then reading a data set, that is Wisconsin breast cancer data. And now what are the input variables? So except ID and diagnosis, remaining other are the inputs, and diagnosis is the output variable. So let's go for that. Now here, so as I'm going to make use of the K nearest neighbor, I need to scale the data. I need to normalize your data. So I'm going to make use of min max scaler from pre-processing, from sklearn pre-processing import min max scaler. Scaler is equal to min max scaler. Transform that data. It is transformed. Now let's split the data in train test format. Okay, so sklearn model selection, train test split, then xtrain, xtest, ytrain, ytest, train test split, scale data. So scale data I'm giving here, training, testing, and then split that data. Then check the shape. So 426 entries are in training and 143 are in testing. And now let's apply the K neighbors classifier. So from sklearn.neighbors I'm importing K neighbors classifier. So import that. Here I'm giving randomly 20 neighbors. Okay, so classifier object I'm creating here, and then K neighbors classifier, number of neighbors I'm giving 20. Many parameters are possible, but out of it I'm giving only neighbors equal to 20. Fine, just randomly 20. Then fit, classifier is fitted. Ypred, okay, remember here I'm giving only single parameter, but all other parameters are also possible when you run this. These are the hyper parameters: algorithm type, leaf size, metric parameters, a number of jobs, number of neighbors. So this value only I have given, remaining are not given there. Okay, then predict it. So on X test we have predicted it, Ypred we got. Fine, and let's check the accuracy. 95.10%. Okay, fine, that's good. Good reasonable accuracy we have achieved by using K nearest neighbor on the Wisconsin's breast cancer analysis data set. Okay, now let's see. So can we improve this accuracy by hyperparameter tuning? So hyperparameter tuning can be achieved with the help of grid search cross validation. Now which ideal set of parameters we can apply to the K nearest neighbor that we can find with this? How to? So from sklearn.model selection I'm importing grid search cross validation. Import it. And now let's see. These are the parameter which I am giving as input to the K nearest neighbor. It means that number of neighbors can be 5, 8, 12, 20, 24 or 30. I don't know what is the ideal value of it. So your grid search will find it. Weights. So weight can be uniform or distance. So here it's using uniform. I can make distance weight also. Algorithms. Auto, ball tree, KD tree, brute. So your algorithm will make ideal combinations of these three: neighbors, weight, and algorithm. And based on that, we are going to find ideal hyperparameters, and which will providing highest accuracy to us. Now we don't know, we are not aware about it. We are going to find that with the help of grid search CV. So parameters are given. Now let's build the object of grid search CV. Okay, estimator is the classifier. Estimator means the name of the algorithm. So here name of the algorithm is classifier, which object I am created over here. Okay, and that's I am providing. Now param grid, which parameter we have to pass. So this is your grid parameters, these three, and any ideal combination we expect from there that I am providing. Scoring means for what we are going to achieve highest accuracy, and how many cross validation you have to do, 5 number of times. So here 5 cross validation will be done, and based on that ideal hyperparameters can be found. So let's create the object of it. The parameters are not executed. Yes, yeah, that's done now. Now this is the object of your grid search CV, k nearest neighbor, and then I'm trying to fit my training data into it. Okay, taking time. Ideal combination can be found. Yes, that's done. Okay, so this is what we got, the object. And now let's see, when the algorithm is trained, we can find the best estimator. So inside the grid KNN object, we are going to have one more variable, that is best estimator underscore, which stores the best classifier object. Means out of all these possibilities, which possibilities are taken for neighbors, for weights, and for algorithm. So check this out. I'm printing it. Check this. Algorithm is auto. Okay. Then number of neighbors are 5, and weights are uniform. Okay. So these are the ideal hyperparameter values for this object that taken. Okay. Getting. And then this best estimator I am storing into variable best. Done. Now let's train with the best. So best will be the object of k neighbors classifier. That's object is stored inside this grid. Okay, that I am storing into best. Then best dot fit x train y train, fit it. Then predict it. Y new is equal to best dot predict x test. And now check the accuracy. So before going to this, I'll check the previous accuracy is 95.10 on my these parameters, or neighbors 20 I have given there. Okay, and now let's check the accuracy for this. Yes, 2% improvement I am achieving from that. 2.10 is that? Yeah, 2.10% improvement, 97.20 with this hyperparameter selection. Okay, so this is how we are going to make this thing. We need to remember these two parts: parameter selections and the grid search object, and passing this parameter using a classifier, not only for k nearest neighbor but for all the machine learning algorithms. This hyperparameter tuning with the help of grid search cross validation is possible. Okay, so ideal parameters for selection of the object is identified with the help of grid search cross validation there. So that's what we have seen. After this, train the model and got the accuracy of it. Okay, these are the cross validation techniques that we can make use of it here in machine learning. So 4 techniques we have seen: k-fold cross validation, then we have seen leave one out cross validation, then we have seen stratified k-fold cross validation, and finally grid search cross validations. So as per your requirements, as per the data set, as per the algorithm selection, we are going to make use of this cross validation technique to validate your data for the given algorithm. Okay, so if you have any doubts regarding the sessions, so things there are in front of you for the communication. Thank you. Thanks a lot.